Hey, sixth graders. Welcome to your last week of geometry. Starting next week, we are going to be moving into statistics. You may have also noticed that I'm in my Green Bay Packer jersey because today is Monday that I'm recording this, and it's the start of Spirit Week. Today is Jersey Sports Hobby Day, so of course, I'm repping my Green Bay Packers. But when you're watching this video, it will be Pet Day, so of course, I can't a video without main man Cam busting in. Do you want to come up here, please? Come on. Everybody's got to say hi to you because it's Pet Day. It's Pet Day. It's a day all for you. All for you. I'm so happy about it. So when you guys see this, it'll be Pet Day. So here's Cam for Pet Day. Yay! Okay, so volume. Last week, you guys started a little bit into volume. You were identifying 3D shapes, talking about what you can do with them. I know it's kind of different, but I just wanted to give you an opportunity to kind of like explore a little bit. We're not going to go as in depth as Khan Academy did, but I do want to talk about the formula for finding the volume of a three-dimensional shape. Okay, so we're going to start off with Y. You can see that I've got the formula written on the board, but I want to talk about why that works. So in my hands, I have a deck of cards, very fitting Vermont cow cards. And I'm going to start with this first card here. And this is just a joker. Now, because I can pick it up, I can touch it, it's a tangible thing. This is technically a three-dimensional object. But the third dimension is really, really hard to see because that's the third dimension. The third dimension is the width here. And we don't really can't really measure that. So we're going to pretend this is a 2D object. It really is 3D because I'm able to pick it up. But we're going to pretend it's a two-dimensional object. Now, beforehand, when we were working with two-dimensional objects, we knew to find the area of our two-dimensional objects is that we multiplied the two dimensions together, right? We would multiply the length times the width, or the height times length, or the base times the height, right? Whatever we call these dimensions, which are called hundreds of different things, whatever we call them, multiplying them together would get me the area of this card. So I'm actually going to measure that to find what the area of this playing card is. So I've got my handy dandy ruler, and I'm going to do this in centimeters because it's kind of small. And I look here, and the dimension here on the bottom is about 5.5 centimeters. So this is 5.5 centimeters, and the height here is 8, perfectly 8 centimeters. So this is 5.5 times 8. So I can figure out the area of this card by multiplying 5.5 times 8, which I'll do right now. So 8, and then 5.5. Remember, I don't have to line up my decimals when I'm multiplying. 5 times 8 is 40, so 0, carry the 4. And then 5 times 8 is 40, plus 4 is 44. There's one decimal point here, so one decimal point, 44. So the area of this thing, this card, is 44 centimeters squared. That's the area of this card. Well, I don't technically know what the width is of this. It's probably pretty tiny, not even a centimeter, maybe not even a millimeter. But the thing is about this card that it's two-dimensional, but if I want to build it to be three-dimensional, I wanted to give it a third dimension. So far, if we were working with length and width, right, length and width, I now want height. To get height, I can grab the rest of the cards. Now, if we think like, okay, if I grab 2 of these, the volume would now have height of 2. This dimension would be of height of 2. So then the volume of 2 of these would be the area of these two added together, right? Double. So now my area would be 88, or the volume would be 88 because I got 2 of these. And then, of course, if I add more to it, okay, now I'm beginning to get a little bit of a height. You can actually see it now when I turn it on its side. Well, all of a sudden, when I add the other 52 of these, right, I now have this other dimension here. Now, when I was talking about doubling that area, like 44 to 88, that would be if my height of the first one was 1. If But my height of the first one wasn't 1. It was a small little tiny number, like a fraction. And that would really change things. Now I actually have a tangible height here, right? And I can figure out the volume of this deck of cards. I already know the area of the face here. So then all I need to do is multiply it by how much my height is. If I just multiply the area of the face, which I know is 44, and I multiply it by the height, I'll find the volume of this deck of cards. So, handy dandy ruler, coming on over here, finding the height. I'm going to turn it my way. Sorry, guys. I know how to work a ruler. It's fine. 1.5. So I multiply this by 1.5. Well, multiplying it by 1 is 44. Multiplying it by a half, well, half of 44 is 22. I add it together. The volume of this is 66 centimeters cubed. And notice I said cubed. We're working with a third dimension now. Because I've got 3 dimensions, this is a 3-dimensional shape. So I'm now going to have this is going to be times 1.5. Half of it was 22. And one more, well, hold on. I'll do this the right way. 5 times 0 is 0. 5 times 4 is 20, carry the 2. 5 times 4 is 20, plus 2 is 22. 1 times 0 is 0. 1 times 4 is, oh, sorry. Placeholder. 1 times 0 is 0. 1 times 4 is 4. 1 times 4 is 4. 66. So it's going to be 66 centimeters cubed to the 3rd power because we're talking 3 dimensions now. So it is 3-dimensional centimeters cubed. And you might be thinking that's not much bigger than what the area of one face was. But remember that the height of this one face was a fraction. It was non-existent. If I had to figure out what that would be, it would probably be like 1/100th of a centimeter. 1/100th of a centimeter would mean that I'd have to multiply this by 0.01. So I'd make it smaller. So the volume of this just one card would actually only be like, I have to move it over 2 spaces. So it would be 44/100th. That's tiny. So it kind of is a little confusing when we start off with something small, but I wanted you to get the idea of area of a face, and then we would multiply it by its height to figure out the volume of what you would create. So that's kind of the same here with this diagram here. If you envision this as my deck of cards, I can find the area of this one face here. And then when I multiply it by its height, I would get the volume of the whole thing. Now we can use volume for numerous of 3-dimensional objects. You can find the volume of a swimming pool. A lot of people say something like that, like how much water can it hold? You can find the volume of like your cup or your water bottle because you're asking how much water can that hold? I actually have my water bottle right over here. And it actually has tick marks on the side to tell you how much it can hold in it. That's volume. So volume is really important because we live in a 3-dimensional world. Everything around us has volume. We have volume. Weird. So we want to know, well, how much can I fit into something like that? Just like the area of a square, how many little squares can I put in it? Now if I have like a big square, how many big cubes can I put into it? Okay. So that was our little introduction on volume. We're going to work with it a little bit this week, and then starting next week, we're going to move into statistics. And then we're almost done with the year. As always, email me with any questions. If you need any help with any of your assignments, I'm always here. And I hope you guys have an awesome week. See ya.